What if the Milky Way is not in an ordinary place at all? What if our home is not in some average corner of the universe, but inside a giant hole, an enormous cosmic void? This is the core question behind one of cosmology's greatest mysteries. Do we live in the cosmic void? Not a black hole, not some sci-fi portal, but something more subtle and unsettling. A vast bubble of almost nothing stretching across hundreds of millions of light years? It sounds impossible, but some scientists believe this could explain one of the greatest mysteries in modern astronomy: why the universe appears to expand at two different speeds. Let me break that down. For decades, astronomers have measured the expansion of the universe, and they should all get the same answer. But they don't when they use nearby stars, like type E supernovae or Cepheid variables. They get one number. When they look at the ancient light from the Big Bang, the cosmic microwave background, they get another number. Both sides are confident, but the answers don't agree. This conflict is called the Hubble tension, and it has shaken cosmology for years. So what's happening? Are our tools broken? Are the laws of physics incomplete? Or is the problem much simpler, that we're standing in the wrong place to begin with? This is where the void idea enters. The universe is not evenly spread. If you zoom out far enough, you see something called the cosmic web. Galaxies gather along massive filaments, like bright threads across a dark canvas. Clusters form where the threads meet, but in between those threads, there are gaps, massive empty spaces with hardly any galaxies at all. We call them voids. Now here's the catch. Some researchers suggest our galaxy, the Milky Way, might sit inside one of these voids, not just at the edge, but right near the center of a bubble called the KBC void. If that is true, then space around us is less dense than the cosmic average. And when light travels through emptier regions, it stretches differently. That means galaxies near us could look like they are racing away faster than they actually are. Our entire measurement of the universe's expansion could be skewed simply because of our location. So what's happening? Are our tools broken? Are the laws of physics incomplete? Or is the problem much simpler, that we're standing in the wrong place to begin with? This is where the void idea enters. The universe is not evenly spread. If you zoom out far enough, you see something called the cosmic web. Galaxies gather along massive filaments, like bright threads across a dark canvas. Clusters form where the threads meet, but in between those threads, there are gaps, massive empty spaces with hardly any galaxies at all. We call them voids. Now here's the catch. Some researchers suggest our galaxy, the Milky Way, might sit inside one of these voids, not just at the edge, but right near the center of a bubble called the KBC void. If that is true, then space around us is less dense than the cosmic average. And when light travels through emptier regions, it stretches differently. That means galaxies near us could look like they are racing away faster than they actually are. Our entire measurement of the universe's expansion could be skewed simply because of our location. The debate has been going on for over a decade, and it is far from settled, and the consequences are massive. If the void explanation holds true, then it would break one of the most sacred principles in cosmology, the cosmological principle. This principle states that the universe looks the same everywhere, no matter where you stand. If we live in a giant void, then that principle collapses. We are no longer in a typical place, but in a rare, almost privileged position. That alone forces us to rethink the foundations of our models. But it goes deeper. If the expansion rate has been misread because of our position, then the idea of dark energy itself may be nothing more than a mirage. For years, scientists have believed dark energy is this mysterious force, pushing the universe apart faster and faster. But if the numbers are skewed by a void, then maybe dark energy is not real at all. Imagine 25 years of cosmology being undone by nothingness. Still, the other possibility is just as haunting. If the void explanation is wrong, then the tension remains, and something even stranger must be at play. Maybe new physics, maybe a flaw in how we understand gravity, maybe forces we cannot yet imagine. In other words, either answer shakes our picture of the cosmos. This isn't just an academic argument. The biggest instruments in astronomy are actively chasing the truth. The DESI survey is mapping millions of galaxies to track how matter is distributed. The Euclid telescope, launched by the European Space Agency, is probing the dark universe with incredible precision. Even the James Webb Space Telescope, though designed for other purposes, is giving us sharper views of galaxies that test these ideas. Every new map, every new dataset, is either tightening the case for the void or pointing toward new physics. So, do we live in a giant hole? The honest answer is maybe. The evidence is suggestive but far from final. Some papers argue the void explains everything neatly. Others insist it falls short. What is clear is that we are standing at the edge of a paradigm shift. Either we confirm that our galaxy sits in a massive bubble, forcing us to rethink the nature of cosmic expansion and even the existence of dark energy, or we reject the void idea and face the possibility that the universe is hiding forces and rules we have not yet written down. And both options are unsettling. One says we are not typical, that our place in the universe is skewed, special in a way that bends a view of reality. The other says the universe itself is stranger and more complex than we can currently explain. In the end, the void hypothesis is less about an answer and more about humility. It reminds us that our perspective, our position, our assumptions can all deceive us. The cosmos is not obliged to be simple or fair. It only is what it is, and our task is to keep questioning, keep checking, and never assume the ground beneath us is stable. And this is what I find most mind-bending, the idea that the answer to a profound, universe-wide problem like the Hubble tension might be found right here, under our noses, because of where the Milky Way happens to be parked. It's humbling to realize that our own cosmic address could be the source of our biggest mistake. So the next time you look at the night sky, remember this possibility. Maybe the stars you see, the galaxies in your telescope, the universe we map with satellites, are all being filtered through a trick of perspective. Maybe we really do live inside a giant bubble. Or maybe the universe is about to surprise us with something even stranger. Either way, the message is clear. Reality is bigger, deeper, and more deceptive than it first appears. And that leaves one question hanging. A question without an answer just yet. If we cannot fully trust what we see from our own cosmic neighborhood, how much of the universe can we truly claim to know at all?